But chances are you won't have seen one of these before, and they're more important than you may think. According to Network Rail statistics, there's about 20,000 miles of track on the national network, and all of this needs to be maintained and periodically renewed. By track I mean everything: rails, sleepers, points, crossovers, fish plates, you name it, needs to be maintained. In past episodes we've joined our permanent way guys here, when they've been going out on track inspections, and more recently when they've been replacing sleepers, and we saw just how much of a job that is. Now it sounds obvious, but before the guys working on the track can physically hand back the railway safe and clear for the passage of trains, it needs to be, well, fit for passage of trains. And one of the things is it needs to be level, or the track geometry needs to be correct. Think about it, you don't want to leave the railway equivalent of a pothole or a speed bump in the way. It makes the journey less than comfortable. If you were to cut a cross-section down the track, you would see a lot of layers. At the bottom you have some prepared earthworks. On top of that you sit some ballast known as the sub-ballast, which mainly helps with drainage. On top of that you then place the sleepers, the rails, tracks, you name it, that goes on top. And then on top of that you then place some more ballast known as the top ballast. Now it's this top ballast which helps you level the track, and the ballast shoulder either sides helps avoid movement from side to side. The ballast itself is granite, and that's because it's a hard-wearing material with sharp and jagged edges. The ballast needs to ensure the track physically doesn't move, and it needs to be able to lock together. So once all the track work has been completed and trains start running over, the ballast will start to vibrate and rearrange themselves and slowly work down and lock themselves together. And that prevents the track moving, which is why you need ballast with jagged edges that can really lock together. If, for example, you tried using pebbles you found on a beach with really smooth edges, well, they just slip around. Nothing would happen, it wouldn't work. Now, the last bit, once the ballast is laid, is called lifting and packing, or jacking and packing, which is what we saw the P-Way guys doing a little bit of. Essentially, they stick jacks underneath the rails, lift it up, and then use shovels to push ballast underneath the sleepers, and that is the thing that levels your track. Now that's quite a laborious process, and that's just for the guys doing 10 miles of line here, and they do a fantastic job. But for a second, imagine you've got 20,000 miles of line to do. Well, you're going to need something a bit more heavy duty. And that's where these come into it. Behind me is what we call a tamper, essentially a machine specifically designed for lifting and packing sleepers. This means essentially you can cover more of the network because you need less people, and it's a lot quicker. The chances are you won't ever see one of these in action. Maybe transiting between locations if you're lucky, because they're really only used when the engineers take possession of the line. So at night time or over weekend blockades, for example, Christmas and Easter. But according to Network Rail, there's about 65 of these dotted around the network, and we're fortunate enough to have one here today. It's been down here at Alresford doing a bit of final alignment on the track geometry, and also has been sorting out a wet bed for us up further up the line at Bishop Sutton, so it's about halfway between Alresford and Rockley. Remember earlier when I mentioned the sub-ballast helps with drainage? Well, some areas are more susceptible than others, and if it gets really saturated with water, it can't support the rails as well, and you might end up getting a bit of a dip. That's called a wet bed. Now, when you get one of these, really the only thing you can do is dig the whole thing out and start again. So that's what we did. Before seam elimination started, we had some contractors in to address the wet bed, and after the ballast had been put down and consolidated, well, it was time to do it with a tamper, which is what they've been doing today. So, how does it actually work? Now this bit's quite clever. Before it does anything, it will do a run across a section of track that is to be worked on. It will then take measurements about where the track is and where it should be in relation to data it's already been given. The way it actually raises the track up is down here at this end. The bits are sticking down are called tines. Essentially they're driven down into the ground under the sleeper, and they shake and rattle and vibrate and pinch together and can lift the sleeper up. There's also clamps as well, or lifting jacks that lift the rail up as well, so you can do proper lifting and packing. The machine operator in the back has a number of controls. They can adjust the height, they can slew it side to side, they can even adjust the tilt, or the cant as we call it. That's used for high speed lines going round curves. Otherwise you'd have to put a speed restriction on. These can also be fitted with a dynamic track stabilizer, or DTS for short. Essentially, the ballast itself is made of granite and they're sharp edges, jagged rocks. Once you put them down and tamper them, well, there's going to be a little bit of air gap in between them. So what you normally do is hand back at a reduced speed, and as the trains run over them, the vibration causes them to shake together and lock and form a secure hold for the rail. Well, the DTS replicates that. It pushes down on the rail and shakes it, vibrates it, and that simulates about a week's worth of traffic. Now, that's a bit overkill for us because the handback speed without a DTS is about 50 miles an hour. And going to be honest with you, if you're doing that down here, well, you've gone a little bit too fast. Now, as a little bonus, you may be wondering exactly how it got here. Most of you may say the mainline connection we have at Alton. And to be honest, that's how I thought as well. But Tampers have a little party trick, which is they have big jacks. They can lift the whole unit up in the air, drive a lorry underneath it, and then lower themselves back down onto it. So yeah, definitely something you do not get to normally see. But that is it from us this time. So thank you to the guys here for being so hospitable to us, letting us in the cab to see how this all works. Thank you to you guys for watching. If you're on YouTube, don't forget to like and hit that subscribe button, and if you're on Facebook, hit that follow button. It may not seem much for you, it's just a click, but really for us it is so much more. So don't forget to do that. But thank you for watching, guys, and we'll see you next time.